Myself Rajakumar, Assistant Professor, Department of Mechanical Engineering, Rogani College of Engineering and Technology. In this video lecture, we are going to discuss about the entropy and availability. What's the meaning of entropy? The entropy is a measure of the disorder of a system. So entropy also describes how much energy is not available to do work. The more disorder a system and higher the entropy, the less of your system energy is available to do work. That is a entropy. So we are going to discuss about this topic in the availability and application of second law. Then what's the meaning of availability? We should know the availability. After that only we can solve the problems related to availability. So availability is a fundamental concept in thermodynamics that measure the maximum amount of useful work that can be extracted from a system as it approaches a state of equilibrium with its surrounding. It is also known as energy and is measure of quality of a system energy as opposite to its total quality. That is a availability. Then you can solve the one problem related to availability. Exhaust gases leave an internal combustion engine at 800 degree centigrade and 1 atmosphere after having done 1050 kilojoule of work per kilogram of gas in the engine. That is CP value of gas 1.1 kilojoule per kilogram Kelvin. The temperature of the surrounding is 30 degrees centigrade. They are asking to find out how much available energy per kilogram of gas is lost by throwing away the exhaust gas. What is the ratio of lost available energy to the engine work? The loss of availability formula, that is the integration of the 303 to 1073, that is a MCP dt into 1 minus T0 by T1. So we know the value of the mass value and ZP value. So we get the value of 425.55 kilojoule. That is the R value we get 0.40528. This is the loss of availability. Then next problem. Lead storage battery used in automobile is able to deliver 5.2 megajoule of electrical energy. This energy is available for starting the car. Let compressed air be considered for doing an equivalent amount of work in starting the car. The compressed air is to be stored at 7 megapascal and 25 degrees centigrade. What is the volume of tank that would be required to let the compressed air have an availability of 5.2 megajoule for air? PV equal to 0.287 T, where T is in Kelvin, P is in kilopascal and volume is meter cube per kilogram. Electrical energy is high grade energy, so full energy is available. So electric 5.2 megajoule, so convert into kilojoule, that is into 1000. The availability of compressed air equal to internal energy U1 minus U0 minus T0 into S1 minus S0. This is the formula for find out the availability of compressed air. So we get the so we put the datas, we get the values delta W equal to T0 into R ln P1 by P0. So we know the value of pressure and temperature value. So from this calculating this delta value, so before that we know the mass value. So find out the mass value. We get 14.311 kilogram. So then specific volume of air 7 megapascal and 25 degree. From this we know the gas equation PV equal to MRT. From this equation we get the value of V. This is the required storage volume, V equal to 0.17485 meter cube. Then next problem, air enter an adiabatic compressor at atmospheric condition of 1 bar 15 degrees centigrade and leaves at 5.5 bar. The mass flow rate is 0.01 kilogram per second and the efficiency of the compressor is 75%. After leaving the compressor, the air is cooled to 40 degrees centigrade in an after cooler. Calculate the power required to drive the compressor. Then the rate of irreversibility of the overall process, that is compressor and cooler. We know the initial pressure P1 equal to 1 bar, so converted into kilopascal. so into 100, and temperature 288 Kelvin, mass value 0.01. From that we know the gas equation PV equal to MRT. So from this we find out the volume. So we get the value 0.8265 meter cube per kilogram. Then we know the pressure, final pressure P2. This is the temperature versus entropy diagram. So initial temperature we know 288 Kelvin and final temperature. So from this value we put the vertical line. So because this is the entropy constant. So for minimum work record, we know the formula for work done for the isentropic, the gamma into P2 V2 minus B1 V1 divided by gamma minus 1. We know all the value. From this we get the value of work done for isentropic. So W equal to 181.55 kilowatt per kilogram. From this value we find out the power requirement of the compressor. So we know the formula M into W actual. So we know this value. From this value we find out the temperature, that is final temperature. We don't know the final temperature, so from this value we find out the final temperature. Then availability loss due to cooling. So integration 313 to 529.25, 1 into 1.005 and 1 minus 288 point temperature T into change in temperature. From this we get the value of 65 from 65.302 kilojoule per kilogram. So finally total availability energy loss, we find out the 126.15 kilojoule per kilogram. Then power losses due to the irreversibility is 1.2615 kilowatt. Thank you.